Hey, Mr. Simons here. Sorry, I'm finishing chewing on a cookie. You'd think I would have the sense to wait to start the video, but well, I didn't. Anyways, this next set of videos is on applying systems of linear equations. So what we'll have a couple videos that are actual application questions, and we'll have a couple questions that are application questions. Well, I don't know how many videos they're going to be on yet. We'll figure that out. And then we'll have one or two questions that are linear equations questions, but, in solving a system of it, but it's like different cases, like stuff you're not used to seeing. So let's just dive in, I like to do, and get started. So this first one. So the thing about this is a kind of a bit of a unique situation because we haven't really screwed around with decimals much. So what I want to show you guys a trick to dealing with decimals. So if you don't like decimals, what you do is you look at, all right, what's the most number of digits to the right of the decimal that I have in the equations, right? And so on this one, in this first equation, right, it's 1, right? So you got one digit to the right. And this one, you got the same. You got one digit to the right, and here, and then here, right? Those are all your one digits, right? So if that's what we have, then we can do this really cool thing with these, is we can take these and we can multiply them by 10, all right? And you always multiply it by 1 with the number of zeros after it. You have a 0 for each digit past the decimal point that you want to go. So if you have one digit, you would do 1 with 1 0, which is 10. If you had two digits past the decimal point, then it would be 100. All right. So we're gonna go. Okay, let's multiply this by 10. And hopefully you guys know the trick that when you multiply something by 10, you just move the decimal over. So this would be 15x minus 19y equals negative 290. And even though that's kind of a big number, it's still a lot easier for some people to see than it is to deal with. All right, and then minus 9y equals 45. All right, so there's that thing we can do. Now, the only problem with this is now, I don't know if you noticed this, but this could have been a substitution problem, right? We could have solved for x, done this, and now when you multiply by the decimal, that kind of takes that away because now you have this going on. So what we have to figure out is we got to go, okay, we're going to have to play around and multiply each of these to get something. So I'm going to look at my, sorry, I don't know why I did that. I'm going to look at my x's, okay, because I think they're the easiest ones to navigate with. So it looks like they both have a common denominator of 30, right? So they have a common denominator of 30. So in order to do that, I got to multiply the top by 2. I got to multiply this bottom one by 3. Now, I also want to make one of these negative, okay, so that we can just add them up. So I'm going to make this top one negative. So we're going to go negative 2. So let's do that and see what we get. So we get negative 30x, we're doing a top equation here, plus 38y equals positive, and then 290, so that would be what, 580, I believe? All right, 3 times 10, so we're on the lower equation now, 30x minus 27y equals 90 plus 45, so 3 groups of 45, would be 135, all right? And so let's just add them up, all right? So boom, that goes away, we get 11y, and then we get 715, right? 715. 5 comes down, 1, carry the 1 over. Yep. All right, and now my last step is to bust out the good old trusty calculator and say, okay, does 15 go into, does 11 go into 715? And hopefully it does, and it does. It goes in a whopping 65 times. And for those of you that don't remember how to divide, right, you just set it up like that. 11 does not go into 7, it goes into 71 6 times. You get 66, bring down your 5, and then it goes in 5, right? 55, and you get 0, right? So y equals 65. And so now instead of substituting this into one of these equations up here, right? One of these, I'm gonna substitute it in this one right here, into this original one. So I have 10x minus 9 times 65 equals 45. All right, so I'm gonna do 9 times 65. It gives me 585. So I have negative 585 here. Right, 10x minus 585 equals 45. We are going to do a little erasing over here and move over. So that means I'm going to add 585. So I'm just going to copy this down for a second. All right, let's add 585. We get 0, 1, 3, 1, 6. I know I'm always in favor of using the calculator, but I do think that you need to know how to do this stuff longhand too, because just for the necessity of testing more than anything. So your zeros cancel, so you get 63 over 1, so you get 63. So your solution is the point 63, 65. And if I go through and I put it in this top one, hopefully it will return that same value for me. So let's do that really quick. And this is where I'm definitely going to use a calculator, right? Because I'm going to actually put it in the top one with the decimals. All right, so we have 1.5 times 63 minus 1.9 times 65 equals negative 29. So let's multiply, and hopefully all my decimals are going to go away. We'll get close at least. 94.5 minus. So I hope I have a 0.5 on this other one, or Houston, we have a problem. But I do. Minus 123.5. Right? So if I do 123.5 minus 94.5 and then make my result negative, I do, in fact, get negative 29 on the left side. So works out. This is my solution. So we're going to stop the video right here. Hopefully this is helpful. Just one technique, you can do this. Now, like I said, if you wanted to just substitute, like solve for x in that lower equation and this equation right here, and then move that 0.9y over to the other side, you could have absolutely done that and then put it in the other equation. I just wanted to show you another method of how to do this so that, hey, decimals make me nervous. I'd much rather deal with big numbers. So if you're cool with that, then let it rip. All right, see you in the next vid.